Good afternoon. I'm Pat Davies from Direct Supply in Milwaukee, Wisconsin, and today I'm talking about maximizing performance and savings with AWS Compute Optimizer. Just a quick introduction. I joined Direct Supply in 2010. I became a platform engineer in 2018, working with AWS. Direct Supply provides products and technology solutions for the senior care market. Everybody is probably on a cost optimizing journey. Hopefully you are. Today I'm focusing on the right sizing portion. But first, shout out to your discounts. There's no engineering effort here, no architecture, reservation savings plans, just really easy things that you should do. And of course, deleting things you don't use and suspending things that shouldn't be running all night. So back to right sizing. It's configuring or reconfiguring your resources to maximize the savings while still meeting your performance goals. So we want to downsize resources without compromising performance, increase or modify other resources to meet performance goals. So we're basically maximizing your AWS spend. So resource optimization is both cost and performance. Challenges of right sizing is typically the data, and the analysis of that data takes engineering effort, and sometimes there's a lot of it. It's also can be error prone. The other thing is that a lot of new services are continually coming out from AWS. There's new EC2 instance sizes, and you may not be aware of them or how they could help your savings or performance situation. So wouldn't it be nice if there was something to help? AWS Compute Optimizer launched in 2019. It's a machine learning AWS service that uses your existing CloudWatch data metrics to find over-provisioned and under-provisioned EC2, EBS volumes, network, Lambda functions, and ECS Fargate resources. Not only that, it makes recommendations on how to improve, either meet your performance goals or save some money. Where is it? Like every other feature, pretty much it's got its own dashboard. It's also integrated with Cost Explorer. It's on the left-hand side, circled there, right sizing recommendations. Also, the Cost Optimizer recommendations can be found right at the instance level. For a couple of years, I've been seeing this little under-provisioned, over-provisioned, don't care, I got to fix a security group. But it's worth taking a click to see if your instance can be perhaps reduced to save some money. Viewing and accessing recommendations from the dashboard, you can list by type, by region. In this case, I've identified a tag to bring up an instance, and it says it's under provisioned in this case. And then if you could scroll over, you could see some other things, including recommendations. And then once you drill down into that, and at the top, that's your current situation, what you're running. And then AWS typically gives you 3 options of what you can do, in this case, to help meet our performance metrics or goals. So it's saying, hey, it's a T2 micro, you'd be better off with a T3 micro or T2 small. And then also at the bottom, it'll show you metrics that you're currently at and metrics that it believes will be in play when you make the actual adjustment. So in here, the blue and the green line are kind of munged together, but the expectation there is it's not going to be much of a difference performance-wise, or it's going to meet your performance goals. So then I get that flip around. The other way of viewing recommendations in the AWS Compute Optimizer console, you can export utilization data and recommendations to a CSV file to an S3 bucket. So you can select different regions, the different resource types, and select all sorts of different columns, utilization, recommendations. I just check them all and let it rip. And the resulting CSV file is giant, hundreds or thousands of rows, 50 plus columns. And the account ID is in scientific notation, so that's fun. So now what? Well, like anybody else wants to see something more pleasant, so I did just pretty it up a little bit so I can see a little bit better what I'm dealing with. Flavor it to taste. we had a question that we were hoping that AWS Cost Optimizer could help us with. It ended up being more of an inventory situation, but this is what we did. We suspected the Windows instances with 2 CPUs or 2 gigabytes of memory were a bottleneck during our patching process. And we wanted to identify those and see how much it would cost to get those upgraded to something with more memory and more CPU. So just using some standard Excel tools, we were able to create some tables with costs and different EC2 types and figure out what's the next class up where we could get both that memory and the CPU. Because you know that the EC2 sizes being t-shirt sizes, you can't spin up a C4 large with 2 gigabytes of memory, and you can't spin up a 2T micro with 16 gigabytes of memory. So the punchline from all that data munging around in Excel was if we were going to upgrade all of our machines to the CPU and memory targets, it was going to be $14,000 more, or 85% increase. So that doesn't sound like a good idea. So then I did some more in this Excel spreadsheet and found out what can we do if we just do the memory upgrades. And in that case, it was about $3,000 more. So this is just an example of what you can do with all that inventory information in that Excel spreadsheet, in addition to recommendation options that AWS will give you. And there's also Compute Optimizer for Lambda functions. It finds which ones are CPU intensive and which ones are memory intensive. A Lambda function that is CPU intensive with over provisioned memory, you should just reduce the memory. It just saves cost and it won't adversely affect your performance. A CPU intensive Lambda can have a recommendation to increase memory, which increases cost, but then the Lambda runs in a shorter amount of time, and it can tend to be a wash as far as, and you get something that performs better for about the same amount of money. The Compute Optimizer for EC2 components, touched on some of these already. CPU memory with monitoring enabled. Network performance, bytes, packets, in, outs per second, storage, throughput, IOPS, and attached EBSs and SSD, and also auto scaling groups. So in some tips for Compute Optimizer, you have to enable it in your console. It uses the last 14 days of data, and that's free. You can expand that to 3 months, but there's a cost that is incurred. Memory metric, like I mentioned, is not available by default. You need the CloudWatch agent. Other sources supported Datadog, Dynatrace, Instana, and New Relic. You should implement tagging standards for any number of reasons, but this is just another one so you can understand who you have to contact when you're going to do some optimizing work, because they may want to know what you're up to. Recommendations are refreshed daily, so keep coming back, make changes, and see how it gets affected. The analysis is, smarter than just looking at the average. If you have something that's very busy during the day and dormant at night, it's not just going to give you the average. It takes those things into account. It's also actively developed. There's new features from it coming out regularly, and there's a link to that. Thanks for joining. Hope I got enough lightning in there to get out in 10 minutes or less.